Well, modeling in CAD can have its ups and downs, and that's what we're talking about today when we're going to make an office chair riser that goes up and down. So to start our riser, I'll make a sketch on the XY plane. I'll make an angled section and then a vertical section, and then come back around. Assigning some dimensions, I'll match the 3 degrees that I put in our chair base. We're going to go with 1.5. From here to here will be 6. And then I can reposition this back to how it was. And I can say maybe my angled section from the origin will be a height of 3.5. We are fully defined, so I'll deactivate a sketch here and we'll go with a revolve, of course, around this axis. Next, maybe I'll add another section, right? We can come onto this face, make a circle, and I'll say I want my circle to be a quarter bigger than the outside of my shaft here. And I can extrude that. Now, an astute person may also observe that in this sketch, I could have approached this to sketch out a line here, sketch a line up, and back down to make all of this one revolve instead of 2 features. And this is something that depends on your design intent and how you wish to approach your part if you were to go and make changes to it. So as we model, keep in mind these multiple ways of making things, because setting it up in a way that means something to you can save you a lot of time in the future. On this top face now, I'm going to make a sketch, and this will be a bracket that will mount to the seat bottom. I'll start by making a line here, and then I'll go to some tangent arcs. Tangent arc here, and then around here, and we'll finish off with a last vertical line. At least I think that's vertical, but I'll add a vertical just to be sure. There it goes. I'll make sure that this point is vertical with the origin also, and we'll give this a dimension, right, so that this arc center is horizontally 5 away from the origin, and I'll say vertically 5.5. And then I will also make sure that we are vertical here, and I might as well make sure that this line ends off on horizontal. Give this a radius of 1. And we'll give this a horizontal distance of 2.125 or 2 1/8. Lastly, we need to say where this point ends up, and I'll be simple and make sure that this ends up vertical from the center point, and we have a fully defined sketch that will just close off with some extra features, right? We'll go with mirror, we'll select everything, and then we can choose our mirror axis. Which I can choose as my z-axis from the tree. And OK. And I'd like to mirror that mirror, of course. And I can choose my x-axis, again from the tree, or from the graphics display, either way. And I think I should add some holes for bolts. Make sure that all of these are equal. And I'll give this a size of 0.5. And we're fully defined there. So I'll deactivate the sketch. We'll do an extrude. I'll say 0.125 for thickness. I'll add a bottom part now. And I'll create a line. And I'll make sure that my line is symmetric. So I'll choose this axis and these endpoints, and now my line will stay symmetric around the origin. And we'll give this And we'll give this from end to end length of 10. Make sure that it's coincident upon that line there. I can add a horizontal constraint on this line. And we'll make sure that these lines here are equal. And we'll give this an angle of 45. And now we simply have 1 degree of freedom, right? How tall do we want to be? So we'll go 2 inches. We'll deactivate the sketch. We'll extrude. Mid-plane. I'm going to go a distance of 4 here. Just like that. So every office chair is probably going to have some mechanism that will allow the chair to adjust in height. And we're approximating the mechanical mechanism in this area to say, okay, this will be where we adjust the height from. We'll probably want a lever of some kind to adjust the height as well, so we can get working on that. And for that, I'll actually create a plane that comes off of this face. And we'll go down a distance of 1.5. Just like that. I'll activate a sketch on that. We'll make a lever right there. We'll call this, how about 7.875? From here to here, we'll give that a dimension of 45. I'll go 5 here, and then I'll add a smooth bend using a sketch fillet. We'll say 1.5, just like that. Deactivate the sketch. Activate our 2D sketch. I would like to create a little point where this line is. So we'll create a sketch figure. I'll choose the end of this arc because that point there, or I can just choose this line too. Create a sketch figure with maintained association, and there is that point. And we'll say maybe a thickness of 0.125 for a little lever coming out. Maybe something a bit more substantial, right? 165. We'll deactivate, and now we can just run a sweep. This will be our path, just like that. Now, I'll create a sketch on the very end of my sweep, right? Because we'll want something to catch your fingers on. I'll create a rectangle. I'll also project this face right here with maintained association to the sketch. And then I can choose a midline constraint. And what we do with the midline constraint is I say I want the center point of this line. So we select the line, but we're really choosing the center point. We want the center point to be on this circle center. Boom, right? And now we've constrained it so that the midpoint of this line will always be on whatever point we specify. Very handy. Give this a height, about 0.25. And we'll go around, how about 0.5? And I'll once again use a sketch fillet here. And we'll call this, and we'll call it 0.1. Just like that, we'll apply and apply. We'll deactivate the sketch, and I'll make a revolve. Of course, I'll choose this line segment as my revolve axis. Now we've got a nice catch for our height lever. I should also make some holes on this face, so I will do that now. I can also choose a midline constraint as before right here and say I'd like that point to be right on the midline. Interestingly, if I were to add the midline constraint over here, it says we are overdefined. And that's because I have two things that tell this line that it needs to be horizontal. So if I get rid of this horizontal constraint, and I can bend the line anywhere that I want, I will now add a midline constraint without any issue. So I'll continue to add some circles here. And I'm going to add some symmetric constraints. Right, I can choose this axis and these circle centers to be symmetric. And likewise, I can also choose my axis and my circles themselves. And the advantage to that is they're the same size, right? So I click the arc of the circle rather than centers on these ones. And on these ones up here, I only click the centers. And now these are symmetric in position, but not in size. So that's an interesting comparison on ways to use the symmetry constraint to have more or less degrees of freedom when you're done. I'll also make these symmetric from here to these centers here. And now all of these are symmetric. So let's define our circle size. We're going to say 0.5. We're going to say 2.5 apart and 1.325. Just like that. We'll deactivate the sketch, and we can also extrude cut some sample holes. I can go into the right view and even visually see what depth I'd be creating. 1/2 inch should be fine. Finally, a lot of office chairs have an adjuster up on the front here, and we can quickly do something like that. This will be a diameter of 1.85. 1.5, and we'll choose a vertical. We'll deactivate the sketch. We can extrude it, maybe a simple 1 inch. And that will be our riser that can theoretically move up and down to control the height of the chair. Obviously there's some mechanical parts and complexities that we have approximated here, which is very common to do, and will represent something like an off-the-shelf part that we can put in that we don't have to worry about adding the detail in this model. And that's how we do it. Let's continue making the chair in the next video.